Today we are going to discuss Lesson 4.2.2 Kinetic Energy. By the end of the period, with at least 80% mastery, students will be able to define kinetic energy, solve problems involving kinetic energy. Kinetic energy is energy of motion. All moving objects that have mass have kinetic energy. The formula to be used in computing kinetic energy is Ke equals 1/2 mv squared, where m is the mass of the object in kilograms, v is the speed of the object in meters per second, Ke is the kinetic energy in joules. Examples of kinetic energy. Using the same examples as potential energy, we can see how the same object that previously had Pe now has Ke. If the rubber band we were stretching to give it Pe were to be let go, it would now have kinetic energy because it's now in motion. Same with the waterfall. When it falls over, it's now in motion. The yo-yo and the arrow from the bow are also moving, giving all these objects kinetic energy. The running football player and the horses have kinetic energy. Let's now solve some problems involving kinetic energy. Recall that kinetic energy is 1/2 mv squared. If we want to solve for m, then m is 2 times Ke all over v squared. And if we want to solve for v, v is the square root of 2 times Ke over m. Solve the following problems. Show your work. Be sure to write the unit in the final answer. Number 1. Calculate the kinetic energy of a 0.035 kilogram golf ball traveling at 18 meters per second. So, since we are solving for the kinetic energy, we use formula number 1. Kinetic energy is 1/2 mv squared. Substituting the values and simplifying, we get 5.67 joules. Number 2, a car traveling with a velocity of 30 meters per second has a kinetic energy of 800,000 joules. Find the mass of the car. So, since we are required to find the mass of the car, we use formula number 2. M is 2 times Ke all over v squared. So, the kinetic energy is 800,000 joules. 2 times 800,000 divided by 30 squared is 1,777.78 kilograms. Number 3. A bullet with a mass of 0.011 kilogram possesses 1,250 joules of kinetic energy. How fast is it moving? So, when you say how fast, we are required to find the speed. So, using formula number 3, we have v is equal to the square root of 2 times Ke over m. Substituting the values and simplifying, we get 476.73 meters per second. Number 4. A 6 kilogram bowling ball moves at 3 meters per second. How fast must a 0.0015 kilogram tennis ball move in order to have the same kinetic energy as the bowling ball? Is this speed reasonable for a table tennis ball in play? So, there are two parts of the solution to this problem. First, we are going to solve for the kinetic energy of the bowling ball and then use that kinetic energy to find the speed of the table tennis. So, kinetic energy of the bowling ball is 1/2 mv squared. Substituting and simplifying, we get 27 joules. Now, we compute the speed of the tennis ball using the kinetic energy of the bowling ball. So, speed of the tennis ball equals square root of 2 times Ka all over m. And substituting the values and simplifying, we get 189.74 meters per second. Do you think this speed is reasonable for a table tennis ball? If there are no more questions, then let the students complete the classwork until the end of the period.